Hey everyone, welcome back to the channel. Let's start with next problem. So we were starting with greedy yesterday. So today we'll be discussing another problem from the same topic, which is n meetings in one room. So if you guys have gone through yesterday's lecture, that is of activity selection, the problem is exactly same. So we'll take this one also, although it is exactly same, but let's understand what are they trying to say. Let me just check if I'm live. Yes, we are. Okay, so have a look. I'll take the test case. What you're given in this question is that you are given that there is one meeting room in a firm, okay, and you are given the start. The start is, let me write the test case 130,585. I'll explain the question, just wait for a minute. And is 2 4 6 7 9 9. Okay, so very similar to what we discussed yesterday. There are n meetings in a room. These are meetings start and end time, okay, and there is only one room in which you can perform these meetings. Now in that room only one meeting can be performed at a time. So at max, how many meetings can you perform, considering these are the start and end times of different meetings? So if I choose to go ahead with the first meeting, right? So I started it at 1 and let's say it ended at 2. You can consider it any 1 p.m. to 2 p.m., 3 p.m. to 4 p.m. and that anything you can consider the unit of time. Then the next meeting, if I choose to go ahead with the next meeting, what is the start time? It is at 3. Only if the previous meeting has ended, only then you can go and start the other meeting. So I know by then this meeting would have gone, okay, I would have completed this meeting. So I'll go ahead with a meeting that starts at 3 and ends at 4. So I can choose this one also. If I want to choose now next meeting which starts at 0 hour, can I choose it? No. Why? Because the existing meeting ends at 4. Now the next meeting that I want to do in this room, it should start anytime after 4 but not before that. So clearly this meeting cannot be considered. If I choose to go ahead with this meeting, it will be, I can definitely go ahead with it. Why? Because 3 to 4 has already ended. Now I can do this meeting. So far how many meetings have I performed? 1 2 3 meetings have been performed so far. Now this is done. Let's check for this one, 8 to 9. If I go ahead with 8 to 9, I can definitely. Why? Because the previous meeting must have ended by then, so I can take this one as well. So now 4 meetings have been completed. Now if I choose this one, can I take? No. So this 5 to 9 cannot be taken because the last meeting that I did is ending at 9, so its start time should be greater than 9, right? So actually for this test case, right, in this iteration, the number of meetings that we got is the answer for it. The reason being, if you closely observe, the end times are already in the sorted order, right? And how does it help us? So even if whatever pattern of start and end times you are given, what we are trying to do, if we, the logic, the intuition behind this problem is that similar means all of this thing is just repetition of what I did yesterday, and that's a little lengthy one. So if you want to get into its depth, what has been discussed, you should watch the previous lecture of activity selection. So this is completely the same question, just the this thing has been, language has been changed, that this time we are performing meeting and the previous question it was the task that we were performing. That's all. Okay, so the thing here is we already have the end array in the sorted order, right? So how it ensures that now whatever iteration I do and compare the start time of the next meeting with the end time of the previous meeting, this comparison if made and it comes out to be greater than the end time of previous meeting, I can go ahead with that meeting, right, and add it to my answer. So this is going to give me the maximum answer only. But the thing is, if this has not been in the sorted order, right, then I would have to check for a lot of combinations. There could have been a lot of possibilities. Why? Because if I have end array in the sorted order, that ensures that only if I have chosen to go ahead with one meeting, now the next meeting end time is anyway going to be greater than that. So if it just depends whether I select it or not based on whether its start time is greater than the end of my previous or not, right? So I don't have to think about other cases whether I should leave it or take it. Just one condition, if it fits that the start time of this should be greater than the end time of the previous meeting. If that follows, I will take it into my answer. Otherwise, I move to the next meeting in the next iteration, towards the next iteration, right? That is all. This is the reason for this test case we got answer in one pass itself, right? So what we did yesterday, in order to sort now, you can choose anything. What we are doing, we are taking a class pair, okay, so that this pair can have a set of start and end times together, right? And then to have the track of these pairs, I will take an array list which will be having these pairs into it. For example, 1 2, okay, other one will be 3 4 in the sorted order of the end times, correct? So now my only task left will be to compare the, if suppose my I is here, I will start the iteration from I equal to 1 if my index is here. So this is the shortened version. Again, I'm saying I'm not going to get into its depth again because we have taken a similar question in the last lecture. So I'm just giving you a recap, nothing else, okay? So I'll just compare if the start time of this is greater than the end time of this. If so, I will increase the count of my answer. For example, if initially you will initialize it with 1. Why? Because only whatever the case be, unless as long as your array's size is not 0, 1 is always going to be in your answer. Why? Don't choose any task, but at least one task can be performed, right? One meeting can be performed any day, any in that meeting room. So 1 is always going to be part of your answer. You just increment the count from here. Now if I can include it, I'll make it 2. You go to the next one. Also, you'll make sure that the previous is pointing any variable that you are taking. Now my previous should be pointing to the meeting that I just performed, its end time. Now I will compare the current meetings. So this is actually a pair. If you take care that we have made this pair get into this array list. So let's say if my current pair is P, so P dot start should be greater than this previous dot end. This is my condition. If this condition holds true, I will increment the count. Here it does not hold true, the count remains same. Then you go to the next pair, which is 5 7, okay? Check for the same thing. And now will you increment update your previous to this one? No, because we did not include it only, right? We couldn't include it into our answer. Previous will stay here. Then your current is this is your current pair. So P dot start, is it greater than previous end? Yes, 5 is greater than that. So you update your previous end with this 7 now. Previous is now pointing to this 7 pair, current pair's end, and increment the count and move to the next pair, which is 5 8 9, correct? Okay. Then you check for, this is your current pair, its start should be greater than this, which is, so you increment the count, make your previous point to the end of this pair, which is 9, okay? Now the next pair, the current pair is 5 9, so you'll check the start of it. So the start of it is 5, it's not greater than 9, so my count remains same, previous remains same. That's the end of iteration. Finally, whatever answer you got in here is what you're going to return, right? So that is all about it. I hope you all understood. So what we are doing, first of all, here, since we are sorting it, we took this array list, right? Or it can be an array list or an array of pair type, right? So we have to sort it, for which we are implementing that comparator method, okay? And that n log n time complexity for that sorting. Before that, since we are iterating over this array, so that we can convert the start I and end I into a pair, into an array list. So on for that. Then we are sorting it, so n log n for that. And then we are iterating over it again to get the final answer. So predominantly it becomes n log n of time complexity. Fine. So that's all about this problem. Let's have a look at the code. Let me just check if. Meanwhile, if Still you have any doubts, you can ask me. This is completely same from what we discussed yesterday. Okay, so no point in repeating anything at all. That's all about then, guys. So let's wrap it up, then see you all in the next lecture. Bye bye and take care. This is the code you can have a look at. Okay, see you all then. Take care.